So we're going to integrate this e to the x sine x by using parts. So we're going to choose our u, and that's just going to be e to the x. I'm going to choose our dv by dx, which is sine x. So we differentiate this, and we get e to the x, and we integrate this, gives us negative cos x. Now we start putting this all back together again. So we have the integral will be equal to negative ex cos x, so that's uv, take away dv or du by dx rather, cos x, and it's a negative cos x, so I'm just going to make that positive, take that negative outside. Now inside this integral that we've got to do, I'm going to do parts once more. So I'm going to choose u to be e to the x, dv by dx to be cos x, so du by dx stays as e to the x, and this will integrate to give me sine x. Now we're going to start putting that whole integral together again, but what I'm going to do is I'm just going to start off with our original integration thing way back that we're trying to find, which is this. It's now equal to negative ex cos x plus, and inside this big bracket we've got this green part here, which is ex sine x minus, and then we've got the integral of ex sine x dx. Now if we look at this, we've got ex sine x here, we've also got the same thing right there. So we're basically trying to integrate again by parts in here. We're not going to do that. We're going to add, we've got negative ex sine x, well let's add that to both sides. So then we end up with two lots of the integral ex sine x dx on this side, and we're left with ex sine x minus ex cos x. So then, because of this 2 here, I don't want to write the whole thing out again, so why don't I divide both sides by 2. So I'm just going to divide both sides by 2, and now add on the constant c, and there's my integral. And this will work for ex sine x, or ex cos x, or ex times 2 sine x.